Hello there, my name is Lukram and welcome to episode 1 of the Logic Guide, Simply Logical. And yeah, today we are talking about the basic things, so we're going to explore what the logic components are, what they do and how you can use them. So with all of that out of the way, let's get right into the video, shall we? The logic components can be found under the Logic tab in the building menu, and these are the AND gate, the OR gate, the XOR gate, the distance sensor, the speed sensor, the altitude sensor, the angle sensor, and the compass. Now, first we're going to talk about the logic gates, and next we're going to talk about the logic components. So with the logic gates here, I'm going to use the OR gate, but these three have the same settings. You always want to have the show advanced ticked, because if you don't, it's going to hide some very important stuff and you don't want that. You can toggle inputs and you have these three little thingies here. Now what is important to know is some little details that these have. For example, the delay, these are in seconds as you might expect, and you can have a delay of 2 seconds. However, this only works on the rising edge. So what this means is that when you give it an input, for example you press space, it is going to wait 2 seconds to give the output. But when you release space, it's not going to wait 2 seconds to release it, it's going to release it instantly. That is a little thing you need to be aware of with the delay. The duration is quite simple, it's how long it's going to give an output. We can set it, for example, to 1 second. So in this example, when we hold space, this is important, when we hold space, it's going to wait 2 seconds and then it's going to hold the output for 1 second and then turn off again. If we let go of space in any point of this, it's going to turn off. So for example, we let go of space after 1 second has passed. These 2 seconds have not passed, but it's not going to keep counting, it's going to stop. And if we press a space again, it's going to start counting up again up until 2 seconds. Then the pause, it's a pause, for example set to 2.5 seconds. And what this would do is a loop, because now when we hold space, it's going to wait 2 seconds and then it's going to hold the output for 1 second, turn off, wait for 0.5 seconds and then turn on again for 1 second, turn off for 0.5 seconds, turn on again, and you get the gist of it. The delay is only at the rising edge. The duration and pause are what's going to keep looping. Just as another quick thing, all the logic components can be used to generate a constant output/input, and usually you would use the altitude sensor or the distance sensor, but you could use any of these and it would still work. Okay, so let us start with the OR gate. This is the simplest to understand, and you're basically going to be using it most of the time whenever there's something you need to do with logic gates, but it doesn't require a specific gate. I would recommend using an OR gate because there's little that could go wrong if you program it incorrectly. Now I'm going to activate the mods. I'm just going to activate the complexity mode just so I can press F4 and get my mouse here to point out things. So first things first, this is the symbol in real life for an OR gate. It's a bit different because the decals wouldn't let me. The sides here are a bit rounded, but an OR gate is basically a little triangle with a curved bottom. And the OR gate, what it does, it's quite simple. It powers with any input that it receives. So you can see input 1 gives it power, input 2 gives it power, both inputs give it power. And that is the OR gate. Next, we're going to talk about the AND gate, and as you can see, this is its symbol. Its symbol has a flat bottom and then a curved top, and that's the real-life symbol of the AND gate. Now, the AND gate only gives an output when all of its components are true. This means input 1 and input 2 must be true for it to give an output. And the wonderful thing about Trailmakers is that you are not limited to just input 1 and input 2. You could add as many inputs as you want, but for an AND gate, all of them would have to be true. Now, there is a little something I want to say about the AND gate, and it is that it is recommended not to put controls directly inside the AND gate. And this is because if you have more than one seed, it's gonna take the input from seed number 1 and the input from seed number 2 as two separate inputs, so you would need two players to press the button for it to actually activate and send the signal. This is a common issue that people have, and yeah, that is the reason why it does that, and we can demonstrate that in a second. So if I press space here and grab my other controls, we'll just unbound them, and now the only input is space, so we can press space and it will go through. However, if we place another seed, now when we press space it doesn't work because there's two seeds bound to the AND gate and both need to be working for the AND gate to give an output. Next up is the XOR gate, and here we can start to see the combinations of symbols, because this is the same symbol of the OR gate, but now it has a little curved line on the bottom. This is because the XOR gate is officially known as an exclusive OR gate, and you can see this because it's an OR gate with the symbol for exclusive. So exclusive OR gate, XOR gate. And what the XOR gate does is it gives an output when only one input is true. So we can see when all the inputs are false, it doesn't give an output, but as soon as we give one input is true, it gives an output. But if we introduce a second input, the output becomes false again. And it doesn't matter which input is true, it only matters that one is true. Again, with Trailmakers, you can have more than two inputs, so you could have three inputs and still when only one input is true, it will make an output. Next up, we're going to move onto the NOT gate, and as you can see, it's already activated, and this is because the NOT gate, you can think of it as an inverter. The symbol for NOT gate is a triangle with a flat bottom and a circle on the top, and the important thing to remember is the little circle, because that's what's going to be used for linking up chains of other gates. Alright, as you can see, this NOT gate is reversing the input, because here the input I give is false, but we're having here a constant input generator that's powering this XOR gate. And this is the first chaining of gates we're going to make, because we need this XOR gate to invert the input we're going to give it. And as we can see, as soon as I press it, it turns off, and if I release it, it turns on. This is because we're taking advantage of the property of the XOR gate. If you remember what I said, the XOR gate gives an output only if one of its inputs is true. So we make sure that this input is always true by having the altitude sensor set to -500, which is the minimum, so it's always going to be above altitude -500. This generates a constant input for the XOR gate. So as soon as we add a second input, there is more than one input in the XOR gate, so it turns off. And this is how we invert a signal. Next up is quite similar, and this is a NOR gate. This is an abbreviation of a not OR, and we can see the symbol is again the symbol for an OR gate, but now with the little circle on top, symbolizing the NOT. And the way we do this is basically the same as the NOT gate, but we add more inputs. So we can have input 1 is true and then it turns off, input 2 is true and it turns off, or both are true and it still remains off. Next up, we're going to talk about the NAND gate, and this is the abbreviation for not AND gate. As you can see, symbol for AND gate with a little circle on top means NAND gate. And the way this one works is we're going to link up two different gates. We have first the AND gate, and then the output of the AND gate is going through a NOT gate, and this is what makes a NAND gate. So we can see one input does nothing, input 2 does nothing, but if all inputs are true, then it turns off. Next is the XNOR, and this is getting into the quite complex territories because it's a NOR gate with an exclusive feature, or exclusive NOR gate. We can see the symbol for OR gate, symbol for NOT, and symbol for exclusive. So we have a XNOR gate. We have here an XOR gate and here a NOT gate. We can show that this is the reverse of an XOR gate because the XOR gave an output only when one of its inputs is true, and the XNOR gives an output all the times except when one of its inputs is true. So we can see one input, it turns off, and as soon as another one gets added, it turns on again. We can keep this going, and as long as there's more than one input true, it's going to stay on. Alright, so now we're going to transition into the logic component blocks, and first on the line is the distance sensor. Most of you know what it does, and what it does is it gives an output depending on whether it has something in front of it or not. However, even if you see that phase is 2 blocks long, it's actually measuring from only one side. We can show this by extending these pistons. So if we extend the bottom one, you can see it turns on when it covers the face of the piston of the distance sensor. However, if we extend the top one, it does not. Unfortunately, there's really no visual difference, so you're gonna have to test it out to check which is the side that it measures from. So the settings of the distance sensor are quite easy. What you have here is the distance at which it's going to check. You have invert trigger. What this does is what it says, it inverts the trigger. So instead of giving an output when something is in front of it, it's going to give an output when nothing is in front of it. The output scale, just as it says, is the power that's going to give, the output value that's going to give, and the distance is in meters. This is important because even if it's not said anywhere, 4 blocks, 1, 2, 3, 4, are 1 meter long. This is important because if we place something, a face, 1 meter away, as you can see from the face of the thing to here, there's 4 blocks, so it's 1 meter. It won't give an output. And you might ask why. And that is because it doesn't start measuring from the face, it actually starts measuring from the middle of the block. So if we move it one back, it is going to go out because we are moving it into place, but we can show that it is half a block in by doing this. Let's see, let's get another one. There we go. There we go. Now we have markers, and with those markers we can check when it gets there. So we can start slowly retracting this until it pops up. Yeah, there we go. And as you can see, it lines up with the first marker set at the middle of the block. So that's how we can confirm that yes, the distance sensor measures from one side of the block and it starts measuring from the middle, not from the face. Next up is the speed sensor. It's very easy to use. It has a side with a little fan and it's going to measure its speed going in that direction, the direction with the arrow. So we can go in and very simple controls. We have trigger below and trigger above basically. So we can set this to, for example, 10 kilometers per hour. And if you have it like normal, it's going to give an output whenever you go over 10 kilometers per hour. And if you set it to trigger below, it's going to give an output when you are under 10 kilometers an hour. Now, it says kilometers per hour and you can change it to miles per hour. If you enable use miles per hour and we update it, you see it changed to 6.2. That is the correct measurement, even though it does say here kph, it is actually now in miles per hour. So we can use this little test car and let me show the things here. Alright, let's set it to 100 miles per hour. So we go 100, super easy. And once we reach 100, it's going to turn on. And we don't have to do anything. If we want to change back to a kph, we just turn it off. And next time we open this, it's 160.9, and it's going to trigger when we get to 160. So yeah, just keep that in mind, that even when it says kph here, it actually takes into account what unit of measurement you are using. Next is the altitude sensor, and we've seen it a little bit before, but we can just take a closer look now. So we have the altitude setting. This is in meters and you can't change this. This is always going to be in meters, just like with the distance sensor. And just like with the distance sensor, it's measuring from the middle and it changes every 4 blocks. Now this frame of reference is exactly what it sounds like. If you set it to ignore waves, it's going to use the value 0 as the normal value, altitude 0 of the map. But if you change it to relative to waves, in the high seas maps where we have the massive waves, it is going to take the value of 0 as the surface of these waves. Trigger below is just like with the speed sensor. What it does is it changes when it's going to give an output. Right now it's set to give an output whenever it is over 1 meter, and if we change it, it's going to give an output whenever it is under 1 meter. Now, an interesting thing that not many people know about the altitude sensor is that if you set it to 2000, which is the max, and you set it to trigger below, this one doesn't really matter, but you set it like that, in the space sector map, it's going to give an output whenever you enter atmosphere. because the altitude sensor in the space sector map doesn't give anything. It says NA when you are in space, but when you get inside an atmosphere, like when you enter a planet or enter the station, it actually changes to measure from a central point in that place. In the Gajina 9 station, the central point is somewhere below the holodeck over the hangar bay. Using that, you can automate some flight assistance to hover in place instead of just falling. And basically all my ships have this. If we take this ship I made out, we can check for the altitude sensor. And another tip is, if you're looking for something, you can grab something, double click, and now you know where the things are. So as you can see, I have two. One is set to -500, and this is doing all the constant input that things need. And on the other side, this one is set to the 2000 and trigger below, and this goes right to all these logic setups, which are set for the gimbal jets for the assistance whenever you are in gravity. This also works in the normal maps because it is also getting an input. Next up is the angle sensor. This one, what it does is it measures the angle it has. We can see it has an arrow and a circle. The direction changes where the blue part goes. The width changes how much of an angle it takes. So we can set it to 180, and it's going to be half, and direction to 90, it's going to turn. And the angle sensor, you go up to 180 degrees, and then if you want to set it over here, you just set it to a negative number, -90, and it goes to this side. And now we have this option, trigger outside. What this does is exactly what it says. Normally the angle sensor is going to give an output whenever the arrow is inside the blue area, but if you check trigger outside, it's going to change that to the arrow giving an output when on the non-blue area. The only thing with the angle sensor is that it only works when you use it like this. It does not work when set horizontally. It needs to be vertical. As you can see, we can rotate it and the arrow keeps pointing up. The compass, on the other hand, doesn't work if you set it vertically, but it works when you set it horizontally. This is basically an angle sensor, but it is set to point into the north direction. And yeah, those are the basic components of logic. I hope this can help you understand how logic components work. And next up in the series, we're going to explore some simple circuits to help your everyday build and improve your automation skills. And with that, bye!